All right, in this problem, we have a tractor that weighs 4,500 pounds, and that acts right at the center of gravity G labeled in the picture. Okay, the back wheels create the traction, so it's a rear-wheel drive. The front wheel just is free to roll along with it. Okay, the coefficient of friction between the back wheel and the ground is 0.5, and basically, I want to figure out if it's possible to pull with 200 pounds of force. I've got some trailer on the back. I need, 1,200 pounds of force. Okay, I want to do that without the wheels slipping or popping a wheelie, A coming off the ground. Okay, so we start with our free body diagram as we always do. Again, 4,500 acting at G. I've got two normal forces, NA and NB. I've got my 1,200 pound force acting right here at P. Okay, and then I have a friction force, okay, acting at the back wheel, okay, which I'm going to put at its maximum force, which is 0.5 times the normal force, okay, which is the coefficient of static friction times the normal force, NB. So there's my free body diagram. Now I need to figure out how much I can pull without slipping and how much I can pull without popping a wheelie. So we'll start with the slipping. Okay, and we will sum the forces about A. Okay, and what we're ultimately trying to do is figure out, what that how much force I can pull. Okay, so I'll sum the moments about A. I've got the weight, so that's 4 feet times 4,500 pounds. I have my P, which is 1.25 feet up, being pulled at 1,200. Again, that's going to be negative. And then I have my normal force over at B, which is going to be 6.5 feet away, and that's going to create positive. Now, the normal force at A as well as the friction go right through point A. Okay, so we've got that. Okay, now again, if slipping is occurring, okay, my force at P is going to be at its maximum. So that's going to be mu s times n, which is 0.5 times nb. Okay, and those are the only forces in the x direction. So putting it to that limit, I know that P equals 0.5 nb. Okay, solving these two equations, these two unknowns, with that assumption that I have slipping going on, where P is at the maximum friction, 0.5 nb. I find out that nb, the friction force, is just a little over 3,000, and I'm able to pull 1,500 pounds. So what that tells me essentially is that yes, I can pull this thing without slipping. Okay, meaning that the load I can pull is bigger than 1,200 pounds. So I can pull up to 1,531 pounds without slipping. Okay, right at that point that I start slipping, I'm pulling over 1,500 pounds. Okay, now we've got to check for tipping. When I have tipping, what I have is NA is coming off the ground, meaning there is no normal force at A. And I need to figure out how much force I can pull for that to happen, which is right here. I sum the moments about B because I want to get rid of those unknowns. I just want to solve for P. So the only force that shows up here, because NA is now 0, NB and FB are both going through that point, so they don't create a moment. So I just have 2.5 times 4,500, and then a negative P times 1.25. So to get this thing to tip, I'm going to have to pull 9,000 pounds. So if I have some sort of load back there that weighs 10,000 pounds, and I try to pull it, and I get all the friction I want, okay, that wheel's going to come off the ground at A. Okay, but clearly what would more likely happen is it slip because it only takes 1,500 pounds to get it to slip. Okay, and again, because that 1,500 pounds is greater than the 1,200 pounds, it is perfectly possible to pull this load of 1,200 pounds. So again, with friction, generally you have to test a couple of things, right? You have to make an assumption and then move through with it. Okay, so you can try both slipping and tipping, see which one's less, and that's what's going to happen, or you make an assumption and then prove it later on. But generally you're going to have to solve the problem kind of 2 times to make sure that you get it, as we did here.